Alright, let's continue. Let me open the table of content first. Okay. We are still on chapter 27 here. Still on homework code. I haven't looked at homework code yet. So, this one. You know what? Let's continue. Is it in this one? No, I think in the homework. Okay. Team marks. Where is it? Bitrate, create, okay. This one, alright. Let's call this thread 1. Okay. And then thread 2. Okay, where is it? This one. Thread 2, thread start, accumulator, okay. And then destroy the attribute, okay. Then join. Okay. Let's try compiling that. What is it? Pedantic. Okay, let's try running that. Okay, the accumulator is 2. Alright. There is that. Okay, maybe let's take a look at the homework code now. In this section, we will write some simple multi-thread programs and use a specific tool called Hellgrind to find problems in these programs. Read the README in the homework. Download for details on how to build the program and run Hellgrind. Thread API. Oh, there's a there's makefile here. Okay. Okay, min raise, min deadlock. Oh. Alright. We're running this, I guess. Right, I wonder whether we need this or not. Currently, I'm not using this flag, right? But maybe I should use that flag. Yeah, currently I'm not sure if using the bitrate flag here have any effect yet. So maybe we will find that out. This is the command, okay. Main deadlock. Okay. In this homework, you will use a real tool on Linux to find problems in multi-thread code the tools is called Hellgrind, available as part of the Valgrind suite for debugging tools. See this for details about the tool, or maybe we can see the main page, I guess. No, I'm not sure if we can see the documentation in the main page. Oh, there is a grind option at least. Let me check. Oh, okay. Looks like the documentation have changed. Is this the one? Or maybe user manual. Or maybe this one. Those manual. Oh, there's a typo here. Should be HTML. Right. Let me try. Yeah, it should be HTML. Okay. If you find any problem here, just keep in mind that this HTML should be HTML instead. Okay. For details about the tool, including how to download and install it, if it is not already on your Linux system, you can look at a number of multi-thread C programs to see how you can use the tool to debug problematic thread code. Okay, first thing first, download and install. Okay, we already done that. Then type make to boot all different programs. Examine the make file for more details on how that works. Yeah, this one. We will install MinRace, MinDeadlock, and then MinDeadlock Global, MinSignal, and MinSignal CV. I'm not sure what CV in here means. Okay. Then you have a few different C programs to look at: MinRace, MinDeadlock, MinDeadlock Global, MinSignal, MinSignal CV, and common threads. Header file with wrappers to make code check error and be more readable. With this program, you can now answer the question in the textbook. Okay, let's take a look at the header first, I guess. Yeah, it's basically wrapper for the pthread function, I guess. Check if the return value is 0 or not. I mean, if it is 0, like this, it means, what is it called? The asset won't be triggered, maybe something like that. But if the return value here is not 0, then the assert will be triggered and we will exit from the program. Something like that. Okay. Okay. Main race. Okay. Common threads. Okay, we have this global variable unprotect access. Okay, return create. Oh, okay. Interesting. First put main race.c, examine the code so you can see the hopefully obvious data race in the code. Let's assume this one. Balance plus plus here. When we create the race condition is that either this one running first or this one. So maybe something like that. Now run Helgrind by typing Valgrind. Okay. To see how it reports the race. Does it point to the right line of code? What other information does it give you? Okay. We can use make like this to install everything, or we can specify what we want to do, I guess. Something like this. Main race. Oh, okay. All right. Threads API. Okay. Should I go? Or maybe, wait. I think you can change directory, right? Change to directory dir before hitting the make file. Okay, we can do this from the, what is it called? From the git root repo here. Make thread API. Guess that one. And then main race. Okay. Is it gonna be in? Okay. I assume it's gonna be in the threads API here. Right, this one. Main race. Okay. Yeah, we can run specific, what is it called? Make file instruction, maybe something like that. I forgot what this means. Okay. Then running thread. Main race. Oh, right. We didn't print anything. Okay. And that make me wonder if we didn't print anything, Why we need STTIO? Is I don't think assert in the STTIO. Right, assert in the assert header here. Okay. Yeah, what is the reason this exists? Can I comment that? And it still works, right? Okay. Unprotect access. Okay, now run Helgrind with this command to see how it reports the race. Does it point to the right line of code? What other information does it give to you? Okay, let me try. Valgrind to Helgrind. Okay. Thread 1 is the programs. Root thread, okay. Thread 2 was created. Okay. Pthread create. Okay. Is this backtrace? Hey, how do I read this? From bottom to the top, maybe? Okay. Possible data restoring writes of size 4 by thread 1. Logs head none 15. This one, okay. This conflict with the previous write of size 4 by thread 2. Okay, thread 1 here is the program root thread. I mean the main, what is it called? Maybe the main thread, something like that. And then we create thread 2 here with this function. During read size 4, okay. Line 15. And this one my thread wrapper. Okay. Start thread. Yeah. Line 8 here. This one. Address. This is 0 byte inside data symbol balance, this one. Okay. Use history level approx or equal none to gain increased speed at the cost of reduced accuracy of conflicting access information. For list of the tag and suppress error, we run with -s. Allows summary to errors from two contexts here. So suppress one from one. Oh. Okay, let's try running this with -s flag here. So what is the suppress one? Oh, is it just the same information? I am not sure. One error in context 1 of 2. One error in context 2 of 2. And previously, yeah, only one. Why is it 2? Is there any difference here? Yeah, I'm kind of curious. Let's check that out. Okay, not that one. Relative this. Oh. Okay. But then again, there's only some information. Right? And the difference here is only this one. Okay. I'm not sure if we need this S here. Okay. Does it point to the right line of code? Yes. What other information does it give you? That information, like the trace here maybe, when thread is created, and then also the trace for the thread to. I'm still not sure what this means. Are we reading from the top to bottom here? Or bottom to the top? Okay. And then this one, I guess. The address of the, what is it called? The shared resource, or in this case global variable here, balance, inside data symbol balance, right? Maybe that's it. that's the information the Helkan give us. Okay, what happened when you remove one of the offending line of code? Now add a log around one of the updates to the set variable and then around put. What does Helkan report in each of these cases? Okay, let's try removing one of the offending line. Let's what is it called? Comment this out, I guess, and then compiling again. Okay, no error. No possible data res warning or something like that. Now add a log around one of the updates to the set variable. Are we already learning about log here? Oh, this one. Okay. Mutec logs. Probably the next most useful. Okay. To add exclusion to a critical section via logs. Okay. Oh. Okay. That is a critical section. Should I add the log inside the worker function here? Or maybe in the main thread or in the main function here. Let me try this main function first. Okay. Pthread mutec with should I use init first? Okay. Pthread mutec initializer. Let's try using this one first. Mutec initializer. And then mutec destroy. Okay. If we are doing this, I assume we don't need to destroy maybe the default value and to make the log usable. This is the dynamic way, right? Using init. Okay. So maybe something like this. Wait a minute. Okay. Yeah, maybe we can use this one. The macro here. Ptech mutrek logs. It is a pointer, okay. And then that unlock. Pthread mutex unlock. Yeah, maybe something like this. I'm not sure if this is correct though. Let me try. Okay. At least it compile. Log at was first observed. But there is still possible data arrays. This one. Interesting. So maybe that's not how we do that. And unlock around one of the update dataset variable and then around put. Oh, around put. Okay, we have only add the log to one of the update. It is this is called this one, right? Maybe we need both of these. Yeah, I'm not sure. Let's find that out. Still possible data race. Possible data race during read. Is this correct or? When this is up to date, okay. I am not sure. Log first observe. Still possible data restoring read, I guess. And this one during write. Or maybe we need global variable for that. I'm not sure. Okay. Oh. Interesting. So we need to certain log, something like that maybe. Again, when I what is it called? When I have different log, right, on the different function here, worker and main. Let me compile that. Valgrind still report a possible data race during either read or write. Yeah, possible data race. But if we use the same log here, like this one, same log for this one and also this one. Wait, I forgot to recompile. Nothing is reported. 0 error compared to this one, 2 error, right? It is kind of the same when, what is it called? When we comment out one of the unprotected access or the offending line of code, right? See, 0 error because we are only updating in this worker function. Okay, interesting. I guess that's how we use log. Maybe, I mean, you can put static, I guess, to make sure it is only in this, what is it called? Only in this file, something like that. Or some people call this translation unit. That also make me wonder, can I put this in this? Okay, no. Yeah. This is global, right? We need, if we put this in here, we need a way to passing this log into the worker here, probably into the argument here, pointer argument. Maybe creates something like struct. Yeah, I'm not sure how many bytes it is. You know what? Let's try that. Whether we can do this or not. And then, what is it called? Thread. Okay. Wait, maybe something like this. Log. Log. Or And then we need to pass this like this maybe. Let's find out. Okay, at least it compiled. Okay, we can do that. 0 errors, right? So we can pass the log into the worker function here. Now I wonder, do we need static here? Maybe not. Let's find out. Yeah. We don't need to make this static. Because by the time we are entering into this function, this variable still exists. Something like that. Okay. Hello, SetPlusXL, welcome. Yeah, I'm currently trying out this homework code section, taking a look at the, race condition using Valgrind here. Oh, right, I'm also checking out this chapter 27 Thread API in the Linux. Okay, now let's look at main tested log. Examine the code. This code has a problem known as that log, which we discuss in much more depth in a forthcoming chapter. Can you see what problem it might have? Let's take a look at this. Check. With this. Okay. Alright. Main tested log. That log here. Okay. Bitrate mutex initializer. Okay. Oh. At the glance, I am not sure what is the problem here. Okay. Bitrate mutex log M1 M2 equal 0. Okay. This is other than 0. I'm assuming this one, right? P1 will be in this branch or using this configuration, and P2 will be using this configuration. But then unlock. Yeah, I'm not sure what the problem here. there any okay. In log acquisition, with a timeout of 0 to generate to the try log case. Both of these versions should generally be avoided. However, there are few cases where avoiding getting stuck, perhaps indefinitely, in a log acquisition routine can be useful, as we'll see in future chapters when we study that log. Okay, we didn't really what is it called? Didn't really take a look about that log in this chapter yet. Can you see what problem it might have? I'm not sure. Yeah, probably the what is it called? The order of the mutex, mutex log initialization here. Maybe now run Helgren on this code. What does Helgren report? Oh, okay. Let me try. That log. Right, make file. Yeah, that log. Okay. Alright. Oh, thread 3 was created. Okay. Log order. Violate. Oh, log order. Okay. Observe incorrect order is acquisition of log. Okay. Right, maybe the problem is this one. The mutex log order. Maybe. By acquisition of log, okay. Okay, let me try changing this. Okay. 0 errors. Alright. It's different from this one error, right? So the order of the log. Okay, interesting. Yeah, I'm still not sure about this information yet. Required order was established by acquisition of log at this address. Okay, was first observed. Okay, M1 and then M2. Is it matter where we change the order? I don't think so. as long as the order is the same, right? Yeah, as long as the order is the same. When we, what is it called again? Okay, mutex stand for mutual exclusion. Oh, I didn't know about that. Okay, now I know. So when we give the lock, maybe something like that. When we lock the thread, we need to give the same order, maybe something like that. Maybe it is according to this one. Lock order violated, right? Okay. Alright, let's continue question 5 on the next session. So that's it for now. Thank you for watching and see you next time. Bye bye.